Good evening, guys. So, yeah, hope you all are having an amazing evening so far, right? Yeah, okay. So, before we jump into the today's session, let me ask you one question. Can you raise your hand, those who have heard about Devin's AI, which was introduced by Cognitions Lab a couple of months back? Yeah, seems like all of you have heard about it, right? For those who haven't heard about it, so the Devin's AI is like the first AI software engineer, right? So yeah, I know that there were lots of arguments that were going on, lots of debates that were going on, because people argued that the demonstration of the Devin's AI was fake, and it's not capable of solving those Upwork jobs as they showed us, right? But despite from those little argy-bargies or the controversies or the debates, if we focus on the core concept of Devin's AI, that means a kind of a system that can plan and execute on its own task to achieve a kind of a common goal, or a system that can learn by its own mistakes, or a system that can do the communication within its own components, and also with an external environment to get feedbacks and do the learning process. So how about a system like that, right? So the core concept behind those kind of systems are agents. So in today's session, let's see how those agents are work and what are the components of those agents. Yeah. So before diving into today's session, let me introduce myself. I'm Nirodya Pussadeniya, and I'm the co-founder of Cynical. So at Cynical, we are providing some cool solutions for our clients, utilizing those latest cutting-edge technologies. And also, we are doing some research and some kind of experiments based on these AI agents and multi-agent systems, or those kind of SOAM intelligence like stuff. Yeah, let's move forward. So I'm pretty sure that all of you have heard about large language models, right? Because it was the biggest buzzword that were used in the last couple of years. So when talking about large language models, it's a kind of a neural network that were trained on vast amount of data. So those kind of neural networks are known as transformer models, right? So the concept, the amazing concept behind this was this self-attention mechanism, which was introduced by the Attention is All You Need paper in 2017. So what it does is, it's doing kind of a prediction for the next word, or predicting the next token of a sequence based on the data that were used to train it, right? So when talking about large language models from Google, we know that starting from BERT model, now we got Gemini 1.5 Pro version as well, which can do many wonders, right? So let me take an example, right? For an example, if we ask a large language model to do our planning for the next vacation, right? So if we throw a prompt to a large language model asking that do our next vacation planning, what it does is, like, it's giving us a kind of a more generic answer or a more generic plan based on the data that were used to train it, right? So we are not getting kind of a personalized answer there. So those kind of systems or the models are known as monolithic models. That means we are just throwing a prompt to the large language model, and we get kind of a answer which is more generic, and it's always based on the data that were used to train it, right? So we are having kind of a static data set there. But people wanted to take one step ahead from those large language models. I mean, to build some domain expertise or the domain specialized systems. That means a system that can have kind of a dynamic knowledge base, right? So we can do, for an example, like I want to build a kind of a chatbot which can answer for the queries that are related to my own organization, Cynical, right? So what I can do is I can take a couple of approaches. The first one is training or a kind of doing some kind of fine tuning a large language model over my organizational data. But this approach is not practical because it costs a lot in terms of computational power, time, and money as well. Right, so, and also there's an issue if the data is getting updated frequently. So we have to do the fine tuning frequently also. So the next approach is we can connect kind of a database which is getting updated frequently to a large language model. And what it does is like when we are asking questions, it can retrieve those details or the data from the data store and use them as the context in the answer building process. So those kind of systems are known as compound AI systems. So let me take an example. I mean, if we go back to our previous example, that was like vacation planning thing. So now I want kind of a more personalized vacation plan. So what I can do is like, I can have a database that contains my details or the hotel details or the flight details or my favoritions. Personally, I prefer beaches over the mountains. So those kind of data can be stored in a database and it can be connected to a large language model to build the answer. So when I ask system to do the vacation planning, what it does is like it retrieving the details from the database and using those data as the context to build my vacation plan. Right, so you might have heard about RAG pipelines, right? Retrieval augmented generation pipelines. So the concept behind these RAG pipelines is this. So as a quick recap, first we had large language models. So those are kind of limited to the data that were used to train it. But people wanted to take one step ahead and wanted to build some sort of systems that are having a kind of updating database or a kind of a more personalized or more domain expertise or more domain specialized systems. So then the compound AI systems came and pipelines like RAG came into the picture. But what we wanted kind of a more intelligent and more autonomous system. For an example, I want to make my system or the vacation planning system with more intelligence. That means that can have more memory, that can take some actions, or that can do the more planning with more generalized or the more personalized way. And it should be capable of doing those actions like hotel bookings, flight bookings. So what about having a system like that? Okay, so that's where the agents are coming into the picture. So first we had large language models, and then we wanted to build more personalized or more domain expertise systems. So the RAG or the compound AI systems came, but we wanted to take one step ahead now. So that's where the agents came into the picture, right? So there we can do much more complex reasoning and much more complex problem solving with much more memory, and can take some actions based on this planning by utilizing a set of tools. So those are the AI agents, right? So when you look at this picture, you can see that why I am telling or why I am believing that the future is agentic, right? So let's see what are the components of an agent. So agent has kind of a memory. It can be short-term and long-term as well. And the most crucial part, it can do the planning process by reflection. Reflection means it can do the re-evaluation or the evaluation of its own outputs or of its own processes and do more iterations until it getting a kind of a more satisfied output. And it can do the self-critics, chain of thoughts, that means reasoning in each step, and do the sub-goal decomposition as well. And based on those planning, or while it's doing this planning, it can do some actions as well. For an example, let's say, right, if we jump back to the previous example, when doing the vacation planning, it needs to do the hotel bookings as well. So what it does is like it retrieving those informations about or the details about hotels from the web and do the booking process. To do those actions, it can utilize a set of tools. For an example, let's say web search tool. To get those hotel details, we can use the web search tool and a code interpreter to run code snippets and get those outputs from those codes, and calendar and kind of a calculator to do the mathematical processing. So by utilizing those kind of tools, the agent can do the actions. So now you have a kind of a overview or a basic idea about agents, and you know what are the components of agents. So let's see what are the workflows or how this agent is working, right? So there are 4 main concepts behind this. First one is reflection. So when it comes to reflection, what it does is like it's doing kind of an evaluation of its own processes, of its own outputs. And it can run through iterations until it get kind of a satisfied output. For an example, let's say writing a piece of code. So what it can do is it can check the code and identify potential bugs or inefficiencies, and then it can run through iterations until it get solve those bugs and efficiencies and get a kind of a better piece of code. So this concept is known as reflection. And then we come into the planning process. So in the planning process, what it does is it can break a complex problem into smaller steps and devise with a kind of a strategy to accomplish the main goal. For an example, let's say if we ask an agent to write an essay, what it does is like it can break down the essay writing process into smaller ones, like retrieving details or the information from the web and writing kind of a draft version and revising it and then rewriting it until it get kind of a more creative essay. So this kind of sub-goal decomposition or the planning process can be happen in an agentic workflow. So the third one is tool usage. To do some actions or to implement those actions while planning, it can utilize tools. For an example, to run a code, we can use the code interpreter tool. We can use calculator to do the mathematical processing, likewise, right? And the most important part, the multi-agent collaboration. So if we jump back to the first example that I took, the Devins AI, a kind of AI software development tool. So there what we can do is we can have multiple set of agents which can communicate within each other and do the process. We can have multiple agents, one agent to requirement gathering and requirement analysis part, one agent to write the piece of code, and one agent to test it, likewise. So we can do the reflection, planning, tool usage, and multi-agent collaboration in an agentic workflow. So now you have a basic idea about what our agents are and what are the components of agents are. and how the agentic workflows are happening, right? So when it comes to agents in Google, so Google has given us kind of latest update from the Vertex AI, a tool called Agent Builder. So there we can do those, or we can build those simple agent or multi-agent systems and integrate in our applications. So let's go through a kind of a demonstration next, and let's see how we can do that. Here I'm building kind of a system that, that is used in a kind of a quiz application. There are a couple of agents. One is to generate some questions for the quiz, and one is to check the answers, right? Okay, so we can jump back to the demo. Yeah, I have got a kind of a recorded video because there are lots of forms filling and typings. To save the time, I got a kind of a recorded video here. So here you can see when we go to the Vertex AI, you can select Agent Builder, and you can add a name here and build your own agent with choosing the region also. So I'm naming it as Demo Quiz Agent, and I'm selecting the region as US. And
a answer checker, which will check the answer. Quizmaster will call the answer checker. So let me first create the answer checker so that I can use it in the Quizmaster. So say answer checker is the name of the agent.
Here you can see the agent building application. So we can name the agent, and we can set the goal and instructions as well. No need to sound. Sound is no need. Sound is no. Yeah, we can go ahead. Yeah, we can do the setting a goal. I mean, giving a kind of an objective or a goal to agent. And in instructions, we can set some instruction to, I mean, defining the process of achieving this goal, right? For an example, I'm building the answer checker agent here. So the goal is the main goal is to check the answers of the user given questions and the answers, and then we can set up some instructions here. Yeah, we can go ahead. So first instruction is to greet the user, and then we can set up some instructions like get the question and the answer. And then check the answer whether it's correct or not with respect to the query. And some amazing feature here is like we can talk to the other agents or the other tools from here as well. By declaring a kind of a $sign, we can connect those multiple agents here in the instructions. And also we can add some data stores and tools as well. We can add databases based on the document data or the web URLs or whatever the data that you want. So we can connect those data to the agents as well. And then the second agent, I guess we can skip a little bit. hold on. So here you can see if I give the dollar sign, we can connect the multiple agents here. I have connected answer checker agent to this one, right? So then agents can do the communication part here. Yeah, we can skip those boring typing sessions. And also we can do the setting up a kind of a example. I mean, to give the workflow of the agents, we can set up kind of an example here. So then agentic system knows to what flow that it should follow. So here we are taking an example like user comes to the system and then greets the agent. So then agent asks a general knowledge question. And if it's if the status of it of this agent is okay, then it will pass the answer and the questions to the answer checker agent, and it will do the answer checking part, and it give the output or the final answer. Yeah, we can go ahead. So there are steps that we can add, like user inputs or agentic, like agent outputs or tool outputs. Likewise, we can create an example from here, and then we can test the agent. Yeah, here you can see there's a kind of a chatbot preview here. So then we can test our agents from here itself. And if I say hi, so it will give us kind of a confirmation to ask whether I'm ready or not. So if I'm ready, we can tell us yes, and then it will give us the first question as what is the capital of France. So when I'm replying it back as Paris, so then it runs the answer checker agent and evaluate my answer. So those kind of multi-agent systems, so a simple agent-based systems can be built using this Vertex AI agent builder. This is just kind of a simple thing that we can do from here, and we can integrate those kind of agentic systems in our own applications as well. Yeah, so now you have an overview idea about what our AI agents are and what are the components of AI agents, and how the workflow or the agentic workflow happens. And we saw kind of a simple demo that of building a kind of a quiz agentic system in using Vertex AI. So yeah, we have come to the end, and yeah, if you want to connect with me, or if you have any questions or feedbacks, you can ping me on any of social media channel, including LinkedIn, Facebook, and Instagram. So yeah, thank you very much. Yeah, this is much more clear, and you can scan the QR code if you want. Yeah, thank you very much again.
The future is indeed agentic. Thank you, Nirodya, for that wonderfully informative session. So, as a way of saying thank you to Nirodya, we have readied a small token of appreciation. To present the token, I'd like to call upon the stage the former GDG ambassador and WTM GDG organizer and former WTM ambassador in Sri Lanka, Ms. Dilini Veerasinghe, and I'd like to Nirodya to come to the front to accept the token of appreciation.